Hello, everyone. I see people popping up right at the start of the show tonight. Thanks for joining. Say hello. Let me know who you are and where you're from. If you're comfortable with that, go for it. And let me know if you're experienced with neurofeedback or biohacking, or you just randomly happen to find this live stream as you were surfing YouTube. So, welcome, folks. We're going to talk about some brain physiology tonight, the cingulate cortices, the anterior cingulate, the posterior cingulate, and how they are involved with the management of our attention, but really at the intersection of where attention and stress live. So I wanted to paint out some of the ways in which these tissues coordinate to control our stress and executive function system sort of together, if you will. For those of you who are watching, please give me an audio check. I tend to have incessant audio quality issues, but I think it's working. I can see the little audio trace thing bouncing, so I think we're good. So the format, per usual, is to do a little bit of neurofeedback that is often aligned with the topic, and then I'll do really a half session of brain training while explaining what it is in that particular session we're doing and how the neurofeedback is working, how it's actually changing my brain a little bit as we sit here. And then I'll get more deep into the topic and maybe show you some pictures or show you some examples and answer more questions, all the while answering questions you have. If you have them, just, sing out. So, hey, Radar Ashwood, welcome tonight. I see you in the chat. Very cool. All right, so I'm going to do a little bit of training on my cingulates. Let me turn off the title here. There we go. I think I'm framed up in the video okay. How do I move it? Like that. Move me over here. All right, so I'm going to select my, let's see. So what I'm doing now is setting up Eager to do some neurofeedback. Eager's in full screen mode. Let me just make it. There we go. So I'm going to plan a session. It's going to read some files. Here we have a configuration screen, and let me change it a little bit. I'm going to remove a couple of blocks and just do a single block of training. So let me remove that. See, I just deleted those, and now we're going to run for, let's do a good 15 minutes. And for the session, for the actual training, I'm going to do the cingulates, a difference protocol, FZ minus PZ. And I'll explain in a moment what that is. And then for protocol, I think I'm going to do 12 to 20 inhibit in the front, so a broad beta inhibit in the front, in the low inhibit frequency range. And then the reward's going to be in the alpha range, 6.5, 6.5 to 9.5. So we're under 10 hertz. 10 hertz is sort of a special break in alpha. And if you're below 10 hertz, you're really in alpha 1 or slow alpha, which is an idling frequency. And if you're around the 10 to 12 hertz range, you're up in the alpha 2 or the fast alpha. And this is sort of a preparatory buzz almost. It's idling, but it's sort of accelerating up towards beta. And you'll often in an EEG see beta waves slowing down into alpha and looking like they're alpha in that frequency range that's in the 10, 11, 12, 13 hertz range. All right, so for our fast inhibit, we're going to do 20 to 32, which is a broad beta. So if you notice, what I'm doing is actually inhibiting from 12 to 20 on the low side and 20 to 32 on the high side. So basically everything from 20 all the way up through 32 is being squashed. And since these are wide ranges, not just 2 or 3 hertz wide, they're 8 hertz wide and 12 hertz wide. And since they're that wide, any individual frequencies that surge out in amplitude might be picked up. But they're not going to be super sensitive to the whole band changing because there's so many individual frequencies in the betas across that many hertz. individual functional frequencies, sort of things called alpha, beta, etc. So within that 12 to 15 range, you have several different betas, including something called sensory motor rhythm. And all right, so the protocol's set up. Let's double check our auto goals or thresholds: 25, 65, 15, and 30. That looks good. What that means is I am going to measure, compared to my brain, a certain percentage, and then allow the computer to run when my brain is in range. So let me see if there's any questions as I set myself up a little bit. Here we go. Slight muffled sound, radar. Let's see, and slight static. Let's see. I wonder what that is. I'm not sure I can fix that if it's not working super well. I can turn it up a little bit. How's that? Does that work any better? That might have worked better. I don't know. If it's tolerable, I may have to troubleshoot this for the next show if it sounds okay. And let me set myself up for some neurofeedback. And I will put some wires on my head now. So I'm going to do some training of my brain. And of course, to do that, we need some electrodes. And I have a bunch of silver electrodes here. And I'm going to grab a couple of flat ones that will go on top of my head, plus one ear clip to go on one ear. So you guys can hear me fine. Thanks, Radar, for confirming that. I will definitely break down my audio and try to figure out why it's muffled a little bit next time. All right, so before I set myself up, let me take the other wires I'm not using and put them out of reach of my cats, because if you do neurofeedback and you have cats, they don't participate and play nice with wires everywhere. They tend to get super excited. So let's move the temptation out of my cat's way. Up here, okay. All right, so now we need some paste. I have a couple amplifiers. These are both pocket and aerobic style amplifiers called the Whiz. That's the U-Whiz, an old 2-channel one. That's the Q-Whiz, which is a 4-channel one. At this point, it's also kind of old. Pocket and Aerobics has discontinued as far as I can tell the Q-Whiz line, and they have a 4-channel version of the U-Whiz now that essentially has most of the internals of this amp inside of it. So it's a nice amp, and it's pretty lightweight. The one I have plugged in is the orange Q-Whiz. So let me put some wires on my head and some wires into the amplifier. So, we're going to talk about the cingulates tonight, and the cingulates are involved, as I said at the beginning of the show, with control over the mix of attention and stress. And what I mean by that is our attention is very much a control-based system, and we tend to have a fairly well-balanced gas pedal and braking system that allow just enough reaction, attention, threat sensitivity, etc. And that lets us control, balance at the point between everything shutting down and everything running away from itself. It's called criticality. And life is sort of balanced at the edge of falling too much into chaos and too much into order. And that's how we have, the ability to do things that are maybe not deterministic, getting philosophical. All right, so electrode, which is an ear clip, goes on an ear, shockingly. We have electrodes for the head. Now, I'm bald, if you hadn't noticed. And one trick, if you're bald, is don't put a pasted up electrode on bald skin without preparing it, because it'll just slide right off. It'll heat up and slide off. So I'm taking a little dab of paste, and I'm going to find a location on my head. Let me line the camera up so I can see what I'm doing. And this is called FZ, the frontal zenith. And it's over the anterior cingulate. And same thing in the back. I can do it by feel on myself. Jennifer Jaws, hello. California girl coasting for brain stimulation. Well, we're a pretty stimulating bunch here, I promise. I would like a transcript posted so you can take notes. Yeah, we'll do that. The way these live streams work is YouTube will post a live stream transcript. It's as early as 2 hours. Often it's up to 2 days after the live stream finishes. It'll have a transcript attached to it automatically. So keep an eye open for that if you want. So welcome for another California person, Peak Brain, the company that I own that does neurofeedback all over the world is headquartered in California. And we have a lot of California clients because of that. So I have some electrodes here. I'm going to take them and put them on my head. And we'll put one in the front. Find that spot that I prepped. There it is. Make sure I'm in the middle. Yeah, close enough. You have about 0.5 centimeter to a full centimeter of leeway before you're really in a different location. And you may have noticed I just pulled the wire so it's neutral in alignment, so it's not going to get in the way. You don't want your wires to be pulling on things, or you'll get weird signals. So I have a couple wires in my head, and I'm going to now plug them into the amplifier. So my ear clip is a black wire. That's the ground. So there's no signal coming off the ear clip. It's just there so the amplifier knows what the 0 point on my head is, or my body. And then I have 2 wires. In this case, the one in the front is yellow, and the one in the back is green. So I'm doing red minus black on this amplifier. It wouldn't really matter so much if I did black minus red and flipped the wires, or in this case, green minus yellow. Because I'm just training amplitudes, or the amount of brain waves. The only thing that'll happen if you flip the 2 ends of the subtraction is you flip the waveform upside down, but you still have the same amount of alpha, beta, delta, etc. that you're measuring for the training. All right, so good to have no wires tangled. There we go. Oh, I do have some tangled, of course. All right, here we go. So now let's kick off some neurofeedback. And what I'm going to do is reward my alpha waves while also letting the rewards happen when my beta waves and very fast beta waves drop away. Let's see here. Run this. There we go. All right, so let's do something pretty basic tonight. Let's do, I don't know, box lights. Doesn't get much more basic than that, but that'll be an easy explanation for those of you who are new. Okay, so the top trace here, you can see that it's initializing. That's my signals coming off the amp. Looking pretty good. We got some brain waves. The gap is set pretty wide. It says the THR equals 200. My threshold to reject artifact is 200 microvolts, which is a lot bigger than my signal, which is only 40 microvolts. So I'm gonna reduce that little threshold compared to average. And what that will do is it'll clip out blinks and movement. And the wire, as you can see, is close to my forehead. So blinks, you know, as I blink here, blink, 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 you can see it show up in the trace pretty easily. So let me shrink this down a little bit. Let's go a little slower, a little smaller, down to 100, let's say. My rule of thumb is to set the artifact rejection for signal excursions to about twice what the amplitude of a stable signal is. So getting down to about 100 for our 50 microvolt signal is fine. There we go. And then you can see that I have 3 bands filtered. This is at 12 to 20. It's kind of small, so let me scale it. Actually, this game will be driven by scaling. So let me actually kick off the game, F11. And there's 3 boxes. Okay. And now that I can see the boxes, let me scale. So I'm going to F9. And it just scaled down a little bit. Let me do the other way. You can see how small that purple box is. I want that purple box to be a little bit bigger, which is the size of my 12 to 20 in this case, brainwaves, the slow inhibit. So let me hit F9. And that selected my scale box. Go minus a couple times. And now you can see I have a larger red box there, purple box. The blue is fine, and the yellow is also fine. So let's leave those alone. Hit F11. That was F12. F11. And then F5 to begin. Okay. Let me bring my OBS back to the foreground. Okay, so here we go. We're doing neurofeedback. The below my head here, we see the 12 to 20 brainwave amount. And then off to my right, you can see the average, which is the amplitude, is about 12 microvolts. So I'm making about 12 microvolts, now pushing 13 microvolts of beta waves in the 12 to 20 range. And the way I've set the protocol up, I want to inhibit or allow those to relax or go down, train them down. And so I've tied the size or the amount of the 12 to 20 brainwaves to that purple box there we can see. And what's happening is it's fluctuating as my brain is making more or less of that low beta frequency range. And the same thing's true of the yellow box. That's the yellow frequency range, 12 to 32, and 20 to 32. And so the higher frequency betas are tied to the yellow box. Now, the blue box is the middle brainwave range. It's not color-coded here because I don't have them in order of frequency. But on the screen below me, you can see 6.5 to 9.5, and that's my reward range. And I'm making about 20 microvolts. Average is 20 microvolts roughly. And so you want to make more of whatever you're rewarding. So I've set a threshold, THR, at 15 microvolts. What that means is whenever my brain is making more than the threshold moment to moment, it lets the game run. In this case, you can probably hear some faint beeps happening in the background. That's the game itself triggering a beep, triggering a reward event. So when my brain spends half a second making lower amounts of 12 to 20, lower amounts of 20 to 30, and larger amounts of 6.5 to 9.5, then the computer will beep at me essentially. And even though my mind isn't that excited by beeps, my brain will notice that it only gets beeps when it happens to trend itself in that direction. And then every 30 seconds or so, we'll reset the threshold. We'll move the computer next to where my brain is and wait for my brain to flex a little bit, and then the beeps happen again. So it's very much an involuntary exercise process of brainwaves, so to speak. So you can do this process while doing other things. You can do this process if you're sleeping. Somebody asked in a forum yesterday that I'm on, they said they get different answers, but does neurofeedback work when you're asleep? If clients fall asleep in the chair or something. And yeah, actually you can train the brain when asleep. Margaret Eyre used to train people who were actually in comas, and it does work, but it's not the same process. And you have to kind of know, you're making different brain waves when asleep. So you might not want to be training brain waves that are dominant with eyes closed or sleeping if you're trying to do like a beta protocol, a beta reward. But if you're training if you're rewarding below 10 hertz, which includes things like alpha rewards or alpha theta, and you're doing it eyes closed, then falling asleep is actually not a big deal because you're not going to go into more than stage 1 sleep during a session, probably. And that's not going to really impair the learning process that we use to do this thing. So the cingulates, I wanted to talk about those a little bit tonight because I've really done a bunch of deep dives over the past 6 or 7 months on different topics. And usually it's a high, lofty topic, and we dig down through some of the physiology and talk about a broad set of interventions. But I wanted to kind of revisit a feature in the brain that crosses several topics, the cingulates. So the anterior cingulate underneath this front wire and the posterior cingulate underneath the back wire are involved with holding our attention on things to some extent, especially the one in the front, which holds our internal attention. What we're thinking about internally, what we're musing about, what we're deciding between, what we're valuing. That's the anterior cingulate. It also helps with selecting from competing thoughts. So you can choose what you're thinking essentially as well. And the one in the back is more outside world focused. So it orients you and selects what you must be or should be attending to in the outside world. That sort of watch the road kind of moment. That's the posterior cingulate doing its job really well. So Radar was asking, stimulating the cingulate causes a release in cortisol and norepinephrine. It can. The posterior cingulate is involved with outside world. So it has a really big role to do in identifying what is necessary to pay attention and then following that where threat is, and it helps you orient your attention to the necessary thing that you got to pay attention to at that moment. And so there is a cortisol response, a norepinephrine response, because there's salience of attention and there's learning that's potentiated during that kind of moment. But it's not so much a cortisol-driven structure, except that the PZ, the back midline posterior cingulate, is also one of the big cortical generators of alpha. And the speed of the alpha is also involved indirectly with some things like blood sugar and cortisol. So you can actually get a cortisol response when training the brain at PZ. And you have to be aware of that. If you try to do beta training, well, especially beta training, you'll create anxiety often if you reward up in the teens at the back midline. There are ways you can get away with this. And also the front midline, you generally wouldn't reward beta, but there are ways you can get away with that. You can train the cingulate like I'm doing, FZ minus PZ, or you could train it FZ minus A1 for the anterior, or PZ minus A1. And in that case, you're really getting a more specific signal on one of the two cingulates. And by doing that, you might have to change your targets a bit. So the one in the front, you generally wouldn't do a beta down training if you didn't have features of beta that were excessive. When doing the back doesn't make a lot of beta at rest, so you can get away with doing broad inhibits. And it makes alpha, the one in the back. When you close your eyes, it's a big generator of alpha under the back midline, around the posterior cingulate. It's the cortical alpha, one of the big speed sort of setters of the brain is back there. So you can get kind of speeding up or slowing down kind of effects if you push on the cingulates hard, kind of like you're jerking your foot on the gas pedal of a car a little bit and hearing it rev, but you're noticing often the mind shift. And if you're doing work on the front alone without the back involved, you might think a lot more about front midline theta and inhibiting theta, 4 to 7. I thought about doing that tonight, doing a 4 to 7 inhibit instead of a 12 to 20. But I thought I would just do a 12 to 20 based on my own brain map. And that's an important point I'll get back to in a minute when I show you some pictures. You really should be aligning the protocol you're doing to the person's brain map. A lot of people can get away with different protocols, but when you have a protocol that's well suited for you, it feels amazing. And when it's poorly suited for you, it does not feel good generally. One of those examples, the cingulates, FZ minus CZ, going after the vertex of the head. You can train features of the anterior cingulate by referencing it to the vertex, to CZ, but it's a different kind of effect than doing it against the PZ. So you have to sort of know the protocol landscape. I have a few of these things broken out on some of the articles I wrote for you, and I'll look at some tonight in a minute. But you have to sort of know the brain's wiring. And also there's a maturational effect. If you're a little kid, you'll generally have a lot more going on in the back midline, even some of the features that for an adult might be happening more at the front midline. So I'm kind of dancing around this, but when the cingulates cramp up, we get kind of specific complaints. And in an adult, the anterior cingulate cramps up, and that selector of focus starts to get stuck in high gear, and we think about the same thing again and again and again. And this is called perseveration. And this can be low key, like getting stuck in your head a little bit, or it can be a little annoying, like having songs all day long, or biting your nails a little obsessively, or picking at things, or it can be actual intrusive thoughts and ritualized ideas, or repetitive behaviors, intrusive behavior, kind of compulsions. So the anterior cingulate really does cramp up pretty hard in things like OCD. And doesn't mean you have OCD if your cingulates are unusual or cramped up or stuck, but it's that flavored phenomena often for many people. So if you see on someone's brain map an excess of beta on the front midline, that's a very different design protocol than a front midline theta excess. They might look this similar. You might see OCD type features, but you're more likely to have stronger anxiety with excess betas. Beta's a gas pedal, so too much gas, if you will, too much activation of that front midline, that project manager in the internal self. Now, if you have too much of the beta in the back midline, the posterior cingulate, we tend to get this threat sensitivity and we get stuck in an evaluation mode, and this is called rumination. So when that gets stuck really hard, really strong beta, often the alpha, the rest mode goes away, and we become really like stuck in this really threatened mode, and the brain has learned the world is not safe, not predictable, and now it's looking for sharks in the indoor pool. It's spending all this energy scanning for the possibility, the evaluation of the possibility of danger, because the cost of missing it a second time is so high. So we get traumatized or we experience things that are really intense and negative, and the brain will resource you a little bit to make sure you don't forget that again. And that can easily get stuck into a high place of sort of dysregulated anxiety. We call that PTSD. So, these circuits are not always these things. Sometimes when the back midline is activated, you're just a lifeguard or a parent with lots of kids, and you handle your activated posterior really well. But often you can see on a brain map, on a QEEG, what's going on for somebody at the level of their sort of cramped up resources. So the cingulates do really select your attention. And again, the one in the front selecting the internal attention, the one in the back is the external attention. So I tend to do this particular protocol, this front to back midline training, tailored to the individual's brain, and then mix some SMR training in, which is involved with executive function broadly and sometimes some sleep. And I call this the downshift or the unclench variant, depending what I'm doing. And it really does create that experience for people of like, softening their mind and putting down obsessiveness, putting down rumination, putting down threat if they wish. And really important, it doesn't rob you of those skills. Like if you are obsessing or ruminating or feeling threat sensitive and you train down over several weeks these resources, you are not left tranquilized and numb and dull. You just have a bigger range. So you're still able to hyper-focus and obsess if you wish, but you're also able to put that down. So the name of the game with neurofeedback anyways is taking small, gentle controls, stretching resources, seeing if you get a little bit of this, of the, goal congruent movement, and then iterating. Neurofeedback is essentially personal training on the brainwaves. But if you do end up getting a brain map and you see features on your brain that you understand that you want to take some control over, neurofeedback's not the only way to go after that. So the cingulates are heavily involved with a bunch of resources, including some of the vagus nerve control, the sort of brain, heart, gut, or gut, heart, brain axis. The heart changes its beat-to-beat timing so you can balance at the intersection of sympathetic activation and parasympathetic rest and repair. And your ability to regulate how well you can balance there, how you can pull back if you wish, lean in if you wish, that's heart rate variability mediated. And the cingulates will help drive some of that because they are giving the body the awareness of that threat, that danger, that thing in near distance, etc. So the cingulates and the vagus nerve are heavily involved. And then you have this sort of gut-brain axis and then brain resources all vying for controlling how activated you are, what you're paying attention to, and if you need to fight or run away. So really important to get some control over the cingulates if you are working with a sort of stressy mode to go after things. So if you do see these resources on a brain map, or even if you just know you have some things that sound resonant, again, neurofeedback's not the only thing you can do. You can go after the vagus nerve itself using HRV biofeedback. That works pretty well and is fairly inexpensive. And you can get some devices for a couple $100 and then do breathing exercises to retrain your control over that vagal tone, which creates, again, more control over that precipice of falling over into more activated, brittle anxiety. So you can also do some things with supplements and nootropics. If you do deal with a lot of anxiety and rumination, if you have that tendency to be kind of brilliant but anxious and then a little bit, bothered and hard to put things down, sometimes you'll see that in a genetic variant where you have unusual MTHFR genes or COMT genes or VAL or MET. These are all genes involved with things like dopamine and serotonin and other neurotransmitter turnover. So you can look at a methylation analysis of your genes and figure out, which B vitamins might make sense to lubricate the brain with to help that turnover. So you can really, with a B vitamin strategy, so to speak, help the brain with its methylation status. And then broadly, you can do it with diet as well, but it's pretty, you can get very tailored, and there's a very sophisticated landscape of functional medicine out there that will teach you to pick the right B vitamins off of your genetics. So that's a good place to start. And if you do have a lot of obsessiveness or some tics or intrusive thoughts, and you're not getting good control over it, don't have good access to neurofeedback, there are good literature papers showing that the supplement N-acetylcysteine seems to have good utility in reducing intrusive thoughts, often very quickly. And I've seen a couple papers showing utility in medication-resistant adolescents and teens with OCD who have intrusive thoughts. And something like 40% of them had a significant reduction in symptomology without many medications, just using NAC, N-acetylcysteine. So again, there's lots of ways that you can take control of the cingulates once you know what you're working with. And I have a couple clients that I develop individualized protocols for off their brain maps, and we can do an awful lot with the cingulates, manipulating how their stress response works, their executive function, and giving a progressive control in that direction. Hey, Sonia, as a neuroscientist, would I go over if the white matter of the brain can be healed over time? The white matter, okay. And if neurofeedback can be of any help. I just pulled off the wires, so let me get the session paused here. So white matter, yeah, maybe the chances are yes. White matter, for those folks that aren't aware, people often conceptualize the brain in terms of white matter versus gray matter. And white matter is comprised of the wiring largely. So you can think of the brain kind of looking like this, with all of these fibers coming out and crossing and going back and forth. And those are white matter tracks or ribbons or wiring. And what they are is insulated neurons, the wire part of a neuron. And the cell body part of a neuron is the gray matter. So when you say white matter, you're talking about, I assume, sort of like neural transmission, You might have some oxidative stress in neurons. There might be some myelin issues, like multiple sclerosis, for instance, is a myelination issue. And there's other phenomena where there's oxidative stress causing degradation in white matter. There's also white matter damage in a few phenomena like multi-infarct disease, where you get lots of little tiny injuries, and you can have white matter from oxidative stress with aging or from poisoning. So depending why there's white matter damage or white matter disease, it would affect how I would recommend going after it. Neurofeedback would probably help because it brings up plasticity pretty high. And so you get a bath of plasticity, and it's likely going to help the brain heal lots of stuff. But there might be other phenomena or other interventions, rather, that could make more sense more quickly for the white matter. Depending on, again, why it's happening, that's the first question. If there's an active source of oxidative stress, really important to pull the fuel off the fire there. And you might know what this is, someone smoking or has diabetes or something, and then addressing that will really help. If you don't know what it is, you might want to have somebody pursue like the Apollo Health program that Dr. Dale Bredesen has developed, which looks at functional medicine, 37 factors that drive brain aging, often through oxidative stress. If you do know why it is, you might want to do things like maybe it is MS and it's a pure myelination, so to speak, issue as far as we know. There's supplements like citicoline or CDP-choline that seems to trigger remyelination and improves neural transmission over time. Even if you don't know why, if there's white matter loss, you might want to try CDP-choline or citicoline. There's also a new compound that's just come out, which is an omega-3 fatty acid bound to choline, LPC-DHA, lisophosphatidylcholine, DHA, or EPA. And there's one brand name that's showing up in bottles called Lysoveta, Lysoveta. No affiliation. I'm not a sponsored channel by anyone at this point. But Lysoveta in the literature, in the animal literature, seems to be really impressive for how it's getting through the blood-brain barrier and triggering healing and recovery in eye and brain. So those are potential strategies to pursue. I would also consider maybe pursuing hyperbaric oxygen or photobiomodulation, exogenous ketones, or dietary ketosis, nutritional ketosis, so to speak, depending. Those all might be strategies depending on the person's need, the complaint, the cause, that kind of stuff. That's how I would go after white matter complaints. And I would probably, use a combination of imaging. I would hopefully have a neurologist on the team, and we would have things like tracked imaging, DTI, or, really, really sophisticated MRI. And then we would do QEEG, maybe SPECT, and you should see changes in data. This is why, I maintain that we do get changes in brains when we do things like neurofeedback, because we see shifts in data that's quite significant. In all kinds of data, SPECT data changes, QEEG data changes, performance data changes, random people notice things different in you when you do neurofeedback. So in terms of white matter, I'm not sure, but I think the neurofeedback would be part of a larger strategy. And the tools we use in neurofeedback, the assessment tools for executive function, for attention, for speed of processing, those would also be sensitive to some white matter changes. And so you could use some of the tools to guide at the very least. Hope that was helpful. Guy Soleil, hey Guy, you have white matter disease. Oh, okay. That must be kind of frustrating. Do you know what the cause is? You don't have to share, of course, but again, that's how I would approach this problem or this complaint in terms of biohacking, is I would go right after any perceived cause and then pull the sources of increased oxidative stress off the pile as quickly as possible, and then work on remediating. El Chatterino, making copies. Does white matter act as the trace or path the signal flows through, and gray matter is the PCB board the trace is layered through? Yes, sort of, except that it's closer to that the gray matter is a CPU itself. The soma, the cell body, is sort of like a little CPU, and the processes, the arms, the axons that are myelinated usually in neurons, they are information connections. Every neuron will have several connections to other neurons, and often multiple branching arms. And then you'll have, we now know, information hubs that are not just the cell bodies, where multiple arms will synapse upon one neuron to change its information structure outside of a soma, outside of a cell body. So we classically think of the cell bodies as the summing or the mathematical, abacus that kind of keeps track of things happening in the arms. But it's not really that simple. There are computational things happening in the axons, and there are information flowing things happening in the cell bodies. So, for instance, cell expression, will change. Just remember that you may have neurotransmitters produced in one place in the cell. Oh, looks like my OBS just disconnected briefly. I was saying that neurotransmitters are also produced, I believe, in the soma largely, but in the gray matter, but then they're transported out to where they need to be and packaged in vesicles. So it's really one cell, and it has an information structure that is, quite huge and flowing throughout the brain. So there's a little bit of a arbitrary distinction, the white matter versus gray matter, because it's all the cells you're looking at. Just visibly, it looks like white versus gray because of the organization of the tissue, clusters in that way. Radar asks, does Dr. Carl Pfeiffer said he had success with octacosanol, vitamin C, vitamin B6, and zinc for remyelination after TBIs? Okay, it makes some sense. I don't know why octacosanol would be helpful, and I don't understand the mechanism either, but it's probably one of those omega-3 fatty acid style mechanisms, if I had to guess. Stephanie Bryant. Stephanie, hi there. Does QEEG show which parts specifically of the brain are damaged and how badly damaged they are? No and no, but sort of. It shows you how unusual a brain is, not how damaged it is. And the more unusual something is, it often gets in the way. It doesn't have to, but brain maps do usually make sense when you ask questions of data. So I'll bring up some data for you in a second here, Stephanie. You had a bad concussion 2 years ago and disabled from it. Oh, that's so frustrating. Your MRI is clean and no one takes it seriously. Your EEG will show that probably. If you're disabled from a concussion, I assume it's like brain fog, slowed speed of processing, no rest from sleep. Hopefully you don't have light sensitivity and nausea still, but it's that kind of non-specific, I assume, neuro type of phenomena. And they do a structural MRI or a CT and don't find anything. But if you do an EEG or a QEEG, which is just the population comparison part, you will see it. You'll see the changes in connectivity. You'll see the neurovascular changes from the concussion. It'll be much more sensitive to functional issues, so to speak, than a CT or an MRI. You would really need an fMRI to see what you're dealing with, and then you would need population metrics to compare it to. So a QEEG is actually a really good tool. A SPECT scan is also pretty good, but you have to go to the Amen centers to have them read it because they're the only people that use SPECT. It's also a little more expensive than a QEEG, and it's a little more invasive. There's some radioactives that they inject in SPECT. But QEEG is just a cap on the head for 20 minutes. So if you can put up with that, you would see your some of your features of brain fog and other concussion stuff in the data. My advice is get a QEEG, if for no other reason, so that you can go, okay, yeah, there it is, and you know it, but having pictures of it can really help you externalize the frustration a tiny bit and not feel quite so overwhelmed. It can help other people see it as well and help them understand what you're going through. And when I do a QEEG, and most people doing QEEGs will also do an executive function test, a 20, 30-minute attention test alongside. And that really does create this really nice snapshot or outlining of executive function resources, especially some of the ones that are impacted by concussion. So, everything. Stephanie has light sensitivity, noise sensitivity, dizziness, brain fog, memory loss, insomnia. Okay. Attention, executive function, and fatigue. Yeah. So all of that is stuff that happens, of course, in post-concussion. Makes total sense. The YouTube app. Oh, so the YouTube app was acting up a little while ago? Oh, interesting. I was also set on, so maybe that was maybe it's very sensitive radar. Stephanie, I'm so sorry you're dealing with that. That's so frustrating. Stephanie, I get people all the time who come to me who no one else believes what they're dealing with. And we can see it really easily on a QEEG, and the executive function outlines it. So get a brain map, and at least you'll have a little bit of peace and some perspective to start working towards some change. Radar, as Radar says here, Stephanie, neurofeedback will often help with all of that. It doesn't help perfectly with TBIs and concussions, but it does help broadly. If with really, really severe concussions and TBIs, there's often actually strong OCD. The cingulates tend to get cramped up. Oh, got some paste on my head still. Let me clean that up. The cingulates get cramped up in OCD, in concussions, really, really commonly. So it's really common to have an anterior cingulate sort of like problem after you've had a concussion. I've worked with a lot of young women athletes, a lot of soccer players who have mild concussions and develop eating disorders after a concussion. And people start treating it like it's body dysmorphia or anorexia or something else. And it's not actually, it's a tic. They developed a tic around certain types of food, and it becomes a little bit obsessive and hard to control their behavior around some food. And it's because they're young women, it's treated as if it's a body-focused psychology, when it's really a mild brain injury causing a fairly classic OCD-like feature. And I've worked with folks that have TBIs a lot, more significant TBIs, and you'll often get an OCD-like flare-up with a significant TBI, and that can actually be more of a problem for some people. But the stuff you're talking about, Stephanie, is all that post-concussion sequelae, all that cluster. That suggests you're still dealing with a post-concussion phenomena, a neurovascular phenomena. Believe it or not, the stuff you're describing is really similar to what people feel like after COVID sometimes, or after other sort of non-impact types of events. So we do get a lot of clustering of these types of symptoms across complaint. Mold or Lyme exposure, chemotherapy can cause a lot of the same brain fog signatures. If you guys want to learn about brain fog, go watch last week's live stream, and you can see my rant on brain fog. I think that was last week. Stephanie, you do get some OCD. Look, so I could cold predict some of the complaints you have with a concussion. We're going to see that if you look at your brain map. You're going to see a front midline activation if you have OCD type features in either theta excess, which is like songs in your head and a tic, or beta excess, which is more structured, complex routine, thoughts and things, or both potentially. And then if you have environmental driven OCD, if you develop like a claustrophobia or an agoraphobia or even misophonia, where you're like rage filled with small sounds. That tends to be the front midline cingulate, anterior cingulate, connected to the right tempoparietal junction. The outside world hitting you is latching the attention into high gear, and it's really hard to ignore and really hard to filter. So you'll see the cingulates often involved with other structures throughout the brain, and this is why we get weird things like OCD after concussion. So again, these are things you should be able to see in a brain map. Your anterior cingulate's probably running 2 or 3 standard deviations above average in how much activation or beta waves it's running, Stephanie. So I encourage you to grab a brain map from somebody, if for no other reason, to know for sure, because if people are telling you this is all in your head, people around you aren't being supportive, get a picture of it and show them, because it'll be validating. And that will be hopefully the first step you can take towards, taking some control of this as well. VJ, hello, sir. VJ explains to us, this explains so much for me. The cingulates, the obsessive part, VJ, or some other aspect? Guy Soleil, I searched neurofeedback and stress. Infralow neurofeedback came up. What is this? So infralow is below 1 hertz, Guy. If it's Guy, please let me know I'm pronouncing it wrong. I'll pronounce it as if you're French. The infralow or infraslow is below 1 hertz. You'll find in the Eager software there's a new setting that's called subhertz, which is very similar. Some brands of it or vendors of it call it infraslow, infralow. There is some difference there in technique, but I'm not exactly sure what it is. But in general, you're not training EEG anymore. You're training deep brainstem frequencies, or if you're doing some stuff that's used in Europe called SCP, slow cortical potential, you're training the DC shift of the brain and not training the individual cortical oscillations, the small little patterns. So the kind of brain mapping and the kind of brain training I do is about hitting phenotypes, or learning about a brain with patterns and then helping somebody learn to take control of those patterns. But infraslow, infralow is really trying to work on the sort of arousal level of the overactivated, traumatized nervous system. So it's used for trauma-informed therapy. It's also used for highly overactivated autistic folks sometimes, who are screaming and stimming. But I don't find infralow or infraslow as controllable or as systematic as working off of a QEEG and having a sort of theoretical framework to move through. So I'm a little bit cautious and haven't done a lot of infralow, infraslow stuff. So El Chatarino, skateboarder syndrome, is that a particular concussion style? Skateboarder syndrome, sounds like you might get it. You're welcome, Stephanie, of course. VJ is saying it was super validating when he saw the severe levels of developmental trauma. Yeah, you can see things on a brain map, and I get comments every day like, "Oh my God, you can see that? Wow, yeah, that's me." It's kind of empowering for many, many people. VJ saw the obsessive part with the cingulate, and El Chatarino agrees it's empowering. Hey, let me switch views here for a second. The Windows, it's actually my OBS for some reason has a lot of trouble with managing continuity of the audio. You guys can hear me now, right? Just give me an audio check if you could before I keep ranting at you. I'm guessing you can, though. Thank you. Thank you, Radar. All right, so what we're looking at is some beta waves and some high beta frequencies. And you notice the high frequency beta has this stripe kind of front to back, and that's the anterior cingulate latching on into high gear, and the posterior cingulate also in high gear. This person had a lot of obsessiveness in the front and rumination and threat sensitivity in the back. So a lot of OCD and PTSD type phenomena, really hard to control their mind. And you'll notice the second row, which is relative power, is blue in alpha. Person had no chill. They couldn't relax their cingulates. Broadly, we can see the alpha that's low in that second row is kind of related to where the betas are taking over. And my guess is that a few of you on this live stream right now, here, live stream challenge, there's a blob of blue in the alpha in the relative power off to the right, kind of in the back there. What does that mean? So we have relative low alpha. The beta is also taking over in that same spot. And this is what I was saying. The cingulates are often interconnected to multiple regions. So there's a little bit of area behind the right ear back there that seems to not be able to relax. It's not making much alpha. That's a little blue blob. And it's tying in to all that beta. Anyone have any ideas? Yeah, VJ, the person's definitely clenched up and able to shift gears. Yeah, absolutely. Really obsessive, kind of full-blown OCD type features. Yeah. The alpha, the blue blob, anyone else have a guess? Anyone else have a guess before I tell you what the answer is? I'll scroll to the next one while we're thinking about it. So that back right is involved with sensory and social input. So this person's obsessiveness had a very, very strong, and their fear had a very strong social component. So this is somebody with an autistic level social processing difficulty, and they're flooded by sensory and social information. So OCD, overactive nervous system, anxious, and a social and sensory flooding aspect to it from that lack of alpha there behind the right ear. So you'll see, let's see, what else do we have here? Somebody else. This is connectivity. So you can see again in the coherence, the red cluster of lines here off to the right on the page, that's hypercoherence and beta. It's over connectivity in that front midline. So Stephanie, the concussion you have will probably show that connectivity kind of stuff, that red in the front midline, but it will also show that red coherence right under my head. That's delta coherence. That's hypercoherent or stuck together delta. This person I'm showing you now had a lot of brain fog. Their delta waves were not letting go, so to speak, and they couldn't think clearly. So they're really anxious and running in high gear, but also really foggy at the same time. So the cingulates have different failure modes. I mentioned earlier, beta, theta, alpha. It can all change, and you can see on a brain map which variant you're working with. Also, we tend to have a lot of low-key, not quite seizure activity when there's a lot going on, severe anxiety, when your brain's unusual, not neurotypical, when there's been injuries. You can have a lot of like low-key seizure activity, and tics, a pretty large percentage of tics have a seizure or like an ictal or a spike event that's behind them. Especially things like Tourette's might have a little discharge event behind them. Again, I mentioned methylation. Here's the methyl and the folate cycle, giving you some sense of why it might be so important. You can see there's inside your mitochondria. Let me see here. I had some other neurotransmitter precursors that might be useful. I want to show you one other page, some other examples. Oh, before we go there though, here's some examples of what you can do to target stuff in the brain. Excess beta and theta, just go after it directly. And you can also go after the back midline in a very similar way. You can do what I did, which is modulating connectivity. So by putting two wires on my head and subtracting the difference between them, I was actually training the relationship between the cingulates as well. So I was inhibiting a frequency range And that means that I'm going to make them more similar because the difference between them isn't being inhibited. And I'm rewarding alpha, which means I'm making them more different. That's theoretically going to make the back midline, which likes to generate alpha, largely generate alpha, and might actually reduce alpha if it's excessive in the front midline. You can also just reward alpha on the back to pull it back from the front in some people. That works for some people as well. So Stephanie, you're saying you may have been having seizures in the beginning. Yeah, it tends to happen with concussions. Let's see what else we have here. Temporal lobe training, as I showed you, can be involved. Anything else? Some other non-neurofeedback brain hacks here. Let me show you another set of images. Bear with me for 1 second while I find my mouse. Little teeny mouse on a really, really big screen. I wasn't kidding. I just lost the mouse. Where'd it go? Oh, other screen. There we go. Okay, there we go. I really need like an AV tech, right, to really help me out with this stuff. All right, so this is, which article is this? This is the stress one, I think, right? Let me see. Oh, this is the anxiety one, just the regular anxiety one. So I want to show you this picture here, this image, this data. So sometimes when you get cingulates activating, you don't just get a little bit, you get a lot. You can see this person has essentially all of the brain waves. The delta is low. The blue beneath my head is low. So the person had low delta. They couldn't rest that tissue really well, but they had extra betas, high frequency betas, and alphas and thetas in the front midline, and the back midline has fast high beta or extra high beta. So you can see that sometimes you get this broad dysregulation. And this person had a lot of, again, very classic stuck thoughts in the front, but also really aggressive songs in their head and biting their nails from the alpha, and a lot of rumination from the back midline as well. So you can see these features, and if you have them, then you can train them with neurofeedback if you wish. Here's an example of, this is actually the cingulates, even though the theta is covering the whole head there. This theta below my head is just covering it solidly. There was a lot of cingulate activation. You can sort of see it in the beta in the back midline, and a lot of anxiety with strong ADHD. What I'm showing you is the before, if you will, and those bars off to my right are the performance test. And the average on tests like that's 100 plus or minus 15. So the purple bars are dipping down into the 70s and 80s, it looks like. The orange bar called prudence or carefulness is dipping even lower. So kind of ADHD-like, very classic ADHD, but this alpha that they're making also meant there was a lot of like anxiety and a lot of inertia because the cingulates were making tons of just generalized alpha, and they had a harder time making beta. So the person was sleepy and foggy and really ADHD and also really anxious and couldn't like get out of their own way. You can see, oh, my head's in the way, but you see how that theta is solid red? And then after a couple of months, it turns not. And you can see that the theta has changed over just a couple of months of neurofeedback. So this is the kind of change you would make when you, oops, I guess it blows up. This is the kind of change you would make when you do neurofeedback is, about a standard deviation of color in areas you're changing over time. Here's another example. I just wanted to show you this one here at the bottom. This is a guy that had all kinds of stuff. You can see that front midline, that anterior cingulate right there in beta. He also had it in theta. He also had it in alpha. Again, that's a very strong executive function with anxiety signature. This guy had some of the worst ADHD, and you can see that in the theta and the alpha. That's the ADHD proper. The theta there, this left side blob is inattentive. This right side blob is impulsive. The alpha is also inattentive. The left front alpha was depression. The front midline beta was OCD. And then behind the right ear was social anxiety. So this guy was, had it all. And I call this particular flavor of brain the gifted poet or the tortured poet if you're not in control of it. Essentially, you have all the thoughts and feels and awareness and everything gets in. And you have all the power with which to catastrophize and obsess and get stuck on all the things you're aware of. So it can really cramp up hard. And this guy turned into a lot of dysregulation. And that's his brain there on the right after doing some neurofeedback for about 30 sessions. So you can see the strong changes in the beta going from 2 or 3, 2.5, I guess, standard deviations off the mean down to basically green. And through this process, he eliminated any symptoms of his ADHD or OCD type stuff going on. Also, his mood got a lot better, and he, was able to remain abstinent from substances. So a lot of change for this individual. And it wasn't the cingulates that gave him these problems, but it was the fact that his brain was such a hot race car burning oil. And when the cingulates are that powerful, they tend to take over and compensate for all kinds of needs. So this is one of the reasons I think maybe we tend to get OCD after a concussion, is because the cingulate in the front goes, gotta select the focus, don't feel clear, and the back midline goes, watch the road, things aren't safe. And they cramp up in response to the fog, almost as a compensatory mechanism to cut through the fog. But that means we might end up with tics or intrusive thoughts or obsessiveness when the cingulates get too stuck. It's a very fine line between being a CEO and having OCD. If your thoughts are having you, it's a little intrusive, but having a steel trap mind that you're in control of can be powerful. And that actually is one of the benefits of neurofeedback, is you give somebody regulatory control over the cingulates without robbing them of that unusually strong activation ability. So you take the person with OCD or PTSD and you teach their brain to stretch those resources so they can hyper-focus or hyper-evaluate if they wish, but they're not stuck there. So Stephanie says, makes sense, cool. El Chatarino, self-preservation mode. Yeah, the back midline especially is scanning and evaluating and orienting you, so it's involved with self-preservation. And the cingulates, working on the cingulates can impact meditation and the holding of the mind. So VG, I don't know if this is on any of my meditation papers, but you're right. When you control the cingulate, you actually do control your meditation a lot better. I think you can tell us a lot about that from your personal experience, VJ. There's a couple of papers by somebody who, she started publishing papers when she was a grad student, and she continues publishing in her lab, in her tenure track job as a professor. I forget her first name, but Dr. Lazar, Lazar, did some papers on meditation and how it changes the brain. And she showed a few things, and some of her grad students in her lab have shown a few things where the cortical thickness that you have will thin out with aging a little bit, especially in the parts of the brain involved with being aware of the body and with concentrating. And if you meditate, even for 20 minutes a day, you sidestep the cortical thinning that happens across age. And I forget if it was Dr. Lazar or one of her colleagues who found that as you meditate, the source of activation on an fMRI is pretty high up on the front midline over the anterior cingulate. But as you meditate more and more and more, the activation of the cingulate moves from the rostral part to the genu, which is the knee, the bend, to the underside of the anterior cingulate. And that actually corresponds with an internally focused sense of self that goes from very strongly I, self focus, top of the head, front midline, to almost a selfless focus where you're not focused on I as part of the equation on the underside of the anterior cingulate. So there's research showing that the point of activation changes as you become better at meditation. You become less selfish. So I thought you would appreciate that. El Chatarino says the alpha wall is awesome to watch when you go into a state of meditation. Yeah, you can see big surges of alpha or alpha theta. If you're doing alpha theta neurofeedback, you can see this crossover state where the alpha climbs and then alpha drops away and theta takes off. So you can see a few of these things, these dissociative or absorption states do show up in the EEG. So these can be fun things to dig into. VJ, you are welcome, of course. So guys, we're coming up on a little past an hour, so thanks so much for your attention tonight. I hope you enjoyed this. As usual, I didn't write any new articles for you tonight, but we do have several on the website that you can dig through and ask questions about. If you're watching this later, please drop a like and a subscribe in the comments, or drop a comment below the video and like and subscribe. And if something came up that you want to learn more about, just please let us know. My job is to do these things about once a week and help hang out and be a neuroscience educator for you, teach you a little bit about the brain, maybe inspire you about brain mapping and neurofeedback if I'm doing my job right. So, thank you, Sonia. Thanks for your kind words and thanks for participating. Really appreciate it. And guys, I will talk to you all at some point soon, I hope. Until next time, though, really take care of those brains, and I will do what I can to come up with a good topic for next week. We'll see. So if you have any ideas, you can let me know what you're thinking. All right. Have a good night. Take care, everyone. Bye-bye.